Hey folks, Chuck Black here. We're doing 52 weeks of Python. We're in week number 51 and we're talking about messaging. In our last lesson, we talked about producing messages, that is, creating messages that will get sent to the message broker. What we're going to talk about in this lesson is consuming messages, that is, this functionality here that listens for messages on the message queue and then takes action when a message is received. What we will be doing is we will be creating a thread that will perform the work that has been requested. That would be a port scan in what I've implemented so far. Once the port scan is complete, it will send an HTTP message back to the Quokka server so the data can get stored in the database, and the user interface can then retrieve the data and print it out in a nice format like you see here. In addition to showing you the code that does this, we'll talk about our message broker, which is Rabbitmq, how to get that installed. We'll also demonstrate for you the niceness of this design, wherein you can have multiple things queuing up and they will get dequeued and the work will get launched in these threads simultaneously, basically allowing us to do concurrent processing of port scans, because as you know, things like port scans, packet capture, traceroute, etc. can have a long time before they complete. So those are all getting launched concurrently. Anyway, that's what we'll be talking about. So hopefully that is of interest to you and you'll stick around and become an expert at messaging. So let's get started. All right, so let's get started talking about this Quokka worker side of the messaging solution that we have. Now, we talked about how the user interface or Postman or whatever we're using makes an HTTP request that says, I want you to do a port scan for this host, a host being either an IP address or the name of a host, and that's going to filter down within our Quokka application into the creation of a message. We are the producer of a message, and we will put that into the message queue. We talked about how the whole messaging system is done via Rabbitmq, and that Rabbitmq provides the message broker that is up and running and taking our messages, and it's going to receive it, put it into the appropriate queue. And what we're talking about right now is how the worker is going to pull that message off of the queue, and then it will launch a thread to perform the work. In our situation, the work will be a port scan, and I showed you a little bit about what that looks like. Here's my worker that's running. I'm going to request a port scan. You can see that it has been received over here. This just popped up. It's starting the port scan, and this will take some amount of time in order to complete as it goes through the port range that I mentioned here, requesting that that our Nmap application is able to scan the device and figure out, okay, what ports are actually open. And then it returns, here's my information that got returned, and you can see in the user interface it is printed out in the same manner. And so the question that we're asking is, what does this code over here have to look like? So let's begin to look at the code that actually implements this. Okay, so what I'm demonstrating here is the design of the Quokka worker side of doing things. As you recall, a request from the user interface will request that a port scan is done. That will result in a message being sent to our message queue. This one Quokka worker, all it does is it listens to the message queue, and when it receives a message, which is a request for work in our case will be a port scan, then it launches a thread to do the port scan. And we're able to achieve concurrency because this Quokka worker is not waiting for the results of the port scan. It goes back and listens for the next message, and then we'll be issuing another port scan as soon as it gets that. And so I've got in the background here, now a little bit more in the foreground, I've got screens that I'm sure you can't see. That's okay. Not interested in you seeing the details, but these are my host screens. And what I'm going to do is I'm going to launch port scans on all 6 of these. This is my Quokka worker thread. I'm going to bring it down here. I'm going to clean up that screen, and then I'm going to run it again There you can see that our worker is running. It says right here it's waiting for messages. So what you're going to be able to see when I click on these is that there will be requests going out for port scans. Some of them will complete fairly quickly. Some of them will take a while, but basically they will all be done concurrently. So let's get started in doing that. There's my first port scan. Here's another one. Here's another one. Here's another one. Here's another one. And here's another one. So these are all started. You will have noticed perhaps that all this stuff is going on in the background. You can see here's the results of one port scan. You can see here's the results of another one. And there's another one, even more, and another one. I suspect that they're going to start popping up here because we have like a 5 or 10 second wait for checking for the results of the data. And you can see that they've all come back. You could tell that they were being done kind of in parallel, we would say. This isn't parallelism, it's concurrency, but we can just in the English language say that they're being done at the same time, meaning in parallel. And here's the result of the first one. Here's the result of the second one. Here's the result of the third one. Here's the fourth one that we did. Some of these have a lot of information, as you can see. Some of them have just a little bit of information. And here's the other two. So we were able to, because of our design, handle all of these concurrently, meaning at the same time, because this request, this worker came in and retrieved a request and launched a thread. So that's how we achieve it. Now we could have done something like this, where we have multiple of these workers, and maybe each of these workers actually does the port scan on its own. And so then we could have had, you know, maybe a pool of 5 or 10 workers who are sitting here and they go off and do whatever they need to do and then complete it. And we didn't have these threads started. But because we've done multi-threading and because we're just dipping our toe into the messaging world, then I decided to do it in this manner. But you can see there's multiple ways to do it. The bottom line, though, is that we were able to do all these requests concurrently. Now, this may not be the best example. You're not going to have 6 of these user interfaces up, but if you were going to be doing something like monitoring devices in the network, gathering configurations in the network, etc., one of your choices, of course, would be to do multi-threading like we've done before. Another choice would be to use a messaging system, especially if you were distributing what you were doing, and then you would have workers that would take a request to get information about a device, whether it's configuration, status, whatever, and would go act on that. That would be another way to implement. Many ways to implement things. This is just one of them, but it's good to understand how this message broker stuff works. So looking at this picture, it occurs to me that I haven't spent enough time talking about the details of this message broker. In fact, if I'm honest, I haven't spent any time talking about it, and I probably need to do that. In fact, I certainly need to do that because you need to have a message broker that you're going to use for passing messages. Now, if you're intermediate or advanced, you may be familiar with this stuff already, but if you're not, then let me tell you how I installed Rabbitmq. Now, one of the ways that you could do it is you could go to these pages that talk about installing Rabbitmq. I'm on Ubuntu, so this would be the page that I'm looking for. It talks about the different ways of installing it. It says use the apt repositories. That's highly recommended. This page, as you can tell, is actually quite long and pretty daunting if I'm honest about it. So what I've done, though, when I did this for Quaco, which is a while ago, is I recorded what was necessary in order to get it working. And so this is what I did. I installed Rabbitmq server, and it does mention on this page that you need to install Erlang, which is the programming language that they use. I do not recall doing that, but it's been quite a while, so if you want me to, I can look back at that and try to find out. I did a cursory look and couldn't find anywhere where I installed Erlang, but you may run into that, and it may, don't recall any issues with this installation, so hopefully you won't have any either. Now for using it in Python, you'll need to do this. So Pica is the name of the library that we use for doing RabbitMQ stuff from within Python, as you've noticed from the last lesson, and so you will need to have that available to you as well. Now, you can always just start this by yourself, which is what you will probably want to do. If you want to tell the system to always start RabbitMQ, then you will do this line right here. Now, these two lines, I will be quite honest with you, I went through and had a few problems getting this user stuff to work correctly. I figured out how to do it. And if you recall from our last lesson, when we were looking at the code that actually did the sending of messages, I set the credentials right here, as you can see, and then I referenced them. This is now commented out, where I referenced the credentials because that's how I set it up. And in this page on the wiki, I'm on my wiki here for Quokka, you can see that I talked about how you actually added the user and the permissions appropriately. What I did this morning before recording this is I noticed that over on my Quokka worker, when I went to receive messages, which is what happens right here, I noticed that, hey, wait a minute, I didn't actually do any credentials, and this seems to work. So at this point in time, I don't have extra knowledge about it because I haven't gone down that rat hole to figure out whether the credentials were even required in the first place. I do have them set, and so that's good, but I'm not actually using them. And as we can see here in the Quokka server, actually in the worker APIs, I actually commented out the one that used the credentials, and I'm not using any credentials, and my Quokka worker is working just fine. I did all the stuff that you will have seen me do in this lesson is done without any credentials. So I'm not sure exactly what's required there. I will look into it. Maybe I'll have an answer for you by the time I do the UI lesson, but for right now, it seems like the credentials are not required, at least for doing this. Anyway, that is the installation. You will need to make sure that you have this broker installed because obviously it's a key component. When we do set up our connection to it and a channel, then when we're executing that code, it needs to be there. Otherwise, this won't work. So that is the message broker, the simple one that I'm using, which is the open source RabbitMQ. Okay, let's start looking at the code. Remember the general design. We have an application, Quokka worker. That's what you see running down here. It's going to be listening for messages, and when it gets a message that requests some work to be done, it's going to launch either portscan, capture, or traceroute, and it will launch them in the form of a thread, and then it goes back to listening for the next message, and that's what causes us to be able to get this nice output. So this is my Quokka worker that's running. Let's look at the code. Now the first question is, where is this code located? It is located in M10 messaging worker. So I have Quokka. That was where we had our Quokka service and Flask and the monitors and all the other good stuff that's running, and the new things that I added. Remember, we have the worker APIs, which we just looked at, which was where we actually go and publish the message to the message queue. And so that is what the Quokka side. Now the worker side, I just have really essentially the Quokka worker, and then I have these three thread classes, and the portscan thread is the one that we will be looking at. I do have these other threads hanging around. They're just copied from my Quokka implementation. I modified portscan thread to behave appropriately for this implementation. I have not touched capture or traceroute at this point in time. If that's something you're interested in and you would appreciate me doing that, then let me know by all means, and I'll look at doing that, because that would be a chance for me to write some more code. I may do it anyway, but I recommend you let me know. Anyway, port scan thread is what we did. And so let's look at Quokka worker and see what happens. Remember, Quokka worker is the thing that is sitting right here. And basically its sole purpose is to listen for messages and then to launch these threads. Hopefully that's solidly in your mind. So let's look at this is Quokka worker. One of the things that it does at the beginning is it says, is this running as super user? And if it's not, then we print out a message that hopefully tells the user that they need to run using sudo. So let's go down to the bottom, which is where the code is, because this is a function and the next one is a function, the next one is a function, and here's main. And if you've pulled this down recently, I've been doing little minor updates throughout the day, and this may be slightly different. You can update it if you want to get the latest code. But basically all this application does is it calls start receiving. So that is living up to this thing that I said, that all it does is it receives from this message queue. And so that is what we're going to look at right now. So start receiving, I define up here. It's the first function that I have. Now this is going to look somewhat familiar here. Basically this is going to mimic, but on the other side, the consumer side, what we did in our worker APIs over here. And the basic idea is you set up a connection, and we're using a blocking connection. You set up a channel, you declare the queue, and then you publish. That's what we did on the other side, on our worker side. What we're going to do is we're going to connect to the broker on the local host. We're going to create a channel, and then we're going to declare this queue. Once again, this is the worker queue. So this is just basically stating our intentions to use the worker queue for this channel. And then what we're going to do is we're going to come through here and we are going to set the callback to use when we get a message. So we're calling on our channel consume, and the queue that we're consuming from is the worker queue. So we've declared our intention to use that queue right here, and here we also need to specify that we are using this worker queue. All the worker queue is a string called queue worker. And this is very important here. On message callback, this says whenever a message is received, I want you to call this function. So we've seen callbacks when we've dealt with Scapy, when we've dealt with PyShark, and I believe when we've dealt with Nmap, although I can't remember for sure. But this is the basic idea, is that when we call this function basic consume, we are passing in, and we've done this with threads as well, we're passing in the name of the object that is a function that will get called when a message is received. And I've called it receive work request. Basically, that is going to get called whenever a message arrived. And it's defined right down here below. And so let's look at receive work request. Now I get certain things in here. It's telling me this is the channel that it was received on. This is the method, and that allows me to do some acknowledgement. The third parameter, I've even forgotten what it is, but as you may know, and I haven't emphasized a whole lot, in Python, a lot of times an underscore can mean a lot of things, but when you see it by itself, it basically means this is a variable that I do not care about whatsoever. And so if you put an underscore here, then when I end up not using it, as I have done in the past in certain situations, certainly in Quokka it's like that, I actually have the name of this parameter, then what happens is nice IDEs like PyCharm say, hey, you declared this, but you never referenced it. What's going on? And so it gives you a warning. And since I don't like warnings, I like this pretty green check mark. I do the underscore here, and that allows PyCharm to be happier. Didn't make any difference in the code and the way that it worked. And now the last thing here is the body. The body is going to be the thing that has the information from the message. So basically, this is going to be the JSON version of what got put in by our worker API. Remember, and can't remember if we went into this enough last time, but basically we take the information that we want to put into the queue, we translate it to JSON. It's coming back to me now. I believe we did do it. See how I'm setting the body equal to that JSON data? That JSON data is coming in handy here. So here on the other side, I've got the body, and I'm going to translate it back from JSON into Python data. And now I've got Python data in my hand. I've received the message. That's all that there is. So basically, let's pause for a second and just appreciate and mentally give a hand to this fabulous functionality that allows us on the one side to put in some Python data. All we really had to do was translate it into JSON, and it gets put in here. And on the other side, all we need to do is translate it out of JSON. I've worked with Python and with Pika and RabbitMq in situations where I needed to, this is called serializing the data, and we used to go through things like Pickle and other mechanisms for translating from data structures that are native to Python into something that can be passed across the network. But now what we have is we have JSON, which is a very good friend to us because we use JSON in many different ways, and this is one of them. It allows us to serialize the data. Marshal the data is another term that you'll hear used, and as it gets sent over there, when it comes back to me, all I need to do is translate it back into the Python format. Now I have work info, which is basically the same thing as what we had over here, which was the port scan info. So this port scan info, I'm going to be getting exactly this. And let's look at it here just so that we know what's in there. What are we going to have? We're going to have Quokka, which is going to be a pointer to how I communicate via HTTP the information that I've received. So this is not RabbitMq stuff. This is where is my Quokka server running. It's running on localhost at 5001. If I had a remote Quokka that I was supposed to be giving the information to, I could pass that in and this would work just as well. Now work type is something that I invented. It will either be port scan, or it will be traceroute, or it will be packet capture. I think capture is the word that I used. The host, since it is a port scan, is going to be the name of the host. And then the token, remember our token is important. I'm not going to be manipulating it, but I do need to pass it back with the data. So remember, we're in the worker side of it right here. We're looking at it on this side, how the data goes in, and when it comes back in our Quokka worker, right now we've got exactly that data. So first thing I'm going to do is say is work type in work info, and if it's not, I'm going to log a message. I suspect I probably should be, what should I be doing? I should not be continuing here, so that's probably a bug in my code. I should make sure that I do that. Well, maybe I want to do an ACK anyway, but I definitely don't want to process the work request. That would cause an error. So there's a defect in my code that I suspect I'll fix after I'm talking about this. So we make sure that the work type is there. The second thing is if work type is there, then we need to make sure that it's in this set of constants. Now I actually handily define those constants right here. What I probably want is a file that is global that can be used by both this side. You notice over here I'm just using a string literal. That's bad programming in a real sense, because I could be printing out portscan or something like that, and I would have a problem and it wouldn't work and I'd have to debug it. So basically I want to be able to reference a constant here, but I'm at least in here I do use it a couple of times, so I want to make sure that I'm using it correctly. So here I am. I want to make sure that the work type is one of the three that I mentioned, and if it's not, then I print this out. So if I had done what I mentioned before and spelled it incorrectly, I at least would log this error in my worker. And probably I want to do a basic ACK anyway, just to let them know that I got the message, because I'm not responding to negative responses, but I definitely don't want to try to process the work requests. So that's my defect. Anyway, we come down here. I give an ACK. Now I do need to do this because otherwise on the other side things are going to time out and bad stuff will happen. So I do want to immediately do an ACK. Now let's pause on this for a second. One of my designs could have been to handle the port scan right here and hold off on doing any acknowledgement, but rather to send the data back. Instead of sending the data back via HTTP as I do, I could have sent the data back via this message broker reply. The reason that that's a bad idea is that these things like port scans or packet sniffs or even trace routes can take a long time. And these channels and messaging within them are very sensitive to not having data acknowledged. So for a number of reasons, I decided to send the data back via HTTP. And now, so I do this ACK immediately, and I don't have to worry about that. It always succeeds. Now the next thing I'm going to do is I'm going to do process work request. I'm passing in 2 parameters. It's probably unnecessary for me to pass in 2 parameters. I could have saved a tiny bit of space if you're actually writing code that runs on a device or is time critical or space critical. You're probably not going to be writing Python. You'll be writing C or some other language like that. But if you are, then be advised that yes, I'm aware that I'm doing this twice, but I'm doing it for readability. Basically, I want to have, when I am within my process work request, I want to have my work type nice and handy right there for me to utilize. So that's why I did that. It was a conscious decision. After I call process work request, I'm going to go back to listening. So process work request is going to do something, and then I'm going to come back and begin listening for the next thing. So let's look at process work request and see what it does. So now that we're done with initialization, let's look at the code that actually gets executed when the thread starts up. Now, run is the method name of the thing that gets invoked when you call start on your thread. There's different ways to do threads, as we learned from our concurrency time. The one that I didn't do quite so much, but I've done in Quokka and I'm doing right here, is you actually create a thread class. In other words, a class that inherits from thread. And when you do that, the way that you start it is you call start, and that will actually invoke the stuff for the thread that will in turn call the run functionality. So that is actually what is going to happen. Now I'm down here printing out this information about what I'm about to do in this particular thread, my port scan thread. Now this code right here is textbook port scan stuff. Remember, we've done this in previous lessons in networking module where we learned about Nmap and other stuff. So I'm calling nmap.portscanner to create a port scanner, and then I just say scan, and I pass in the host and the port range, which I got from my information that I set during the initialization. I didn't get that from the information. I arbitrarily set it right there. You could make it more extensible if you pass that in your version. And then there's the scan arguments. Remember, the scan arguments are these things that we initialized it to right there. And then we send the scan off to do its thing. And as you recall, it will take anywhere from maybe 5 seconds to 120 seconds or more in order to complete scanning the entire device. Once I'm done with it, I print it out, and then I call process scan. So what am I doing with process scan? Well, I'm taking the scan output that I received, and let's look at it. Basically, I'm going to call into this function that I've created called send port scan, and I'm going to be passing in The name of this host, that's so I can put that in the data that identifies where this actual port scan came from when it gets put into the database here. Once I send this back and it gets set into the database, then that will be an indication of who was the source of this particular scan. I'm going to pass in the destination. That's going to be the location that I'm going to do HTTP to. So the destination would be right here, this device and this port. That's what that is. The host is the host that I did the scan for. The token is the thing that got passed in. Remember, we didn't do anything with the token. It was given to us, and we're just making sure that it's passed back so that it can be acknowledged. I'm setting the time that the scan was done, and I'm passing back the scan output. And that is what I'm passing into this function that I've defined called send port scan. I'm going to go into this, and as you can see, if you are paying attention, this is in my util function, which is down here, also part of my messaging worker package. And I have send functions for port scan, trace route. Do I have send capture? That's my packet capture. So yeah, this is my send the port scan. And there's not a ton in here, but what I do is I set up the payload. That's going to be the data that is sent back on this HTTP request that I'm sending to the Quokka server. So I'm sending this port scan results up to the Quokka server so it can store it in the database so the user interface can get it and eventually print it out like you see it right here. So what I'm going to be doing is I'm going to set up the payload, the source. You can look into these. I'm not going to spend too much time on these. This is the data that I passed in. The source is the actual IP address of the device on which the runners, the scanner, the worker is working. The host name is the host that I was requested. The token is that important piece of data. The timestamp is what I did. And P format is just going to be a pretty print formatting of the scan output. So it actually takes the scan output and does it in a pretty print manner so that it actually will look like this when I print it out over here. So it actually is making sure that it has the indentation and the line feeds and everything correctly. And then I'm using the requests library. So this is that Python library that makes it easy to send HTTP requests, and I'm doing a post. And this is going to be the URL that I'm passing it into, worker/portscan. I suspect if I was to look at send traceroute, you can see this is going to be different because I haven't modified that yet. This is my Quokka version, the real Quokka project that I did that probably I touched this code 6 months ago, but we built something new and we called that endpoint worker/portscan. So you can call it anything that you like, but just be aware if you're looking at this send traceroute code and also the one for the capture, I haven't modified that yet. So it still exists in its old format. So this is the newer way that we're doing it because I've only implemented portscan. Anyway, I send that. I make sure that the response is 204 like I'm expecting. If it's not, I print it out. And that is kind of the round trip of how now you know how the message got put into the message queue. You know how our Quokka worker retrieved it from the message queue. We saw how it took the data and it created a thread. The thread ran the port scan appropriate to the data that it was passed. When it was done, it sent an HTTP request back to the Quokka server, and I will, you can look at what we did in the last lesson, but we talked about how the data gets taken on that request and gets put into the database. And that is how we do this. The message broker, the message producer, the message consumer, the thread that gets created, the HTTP with the data, and the storing it in the database. So let's just take a moment and appreciate everything that you have learned that you're putting into use here. First, we have this Quokka server, which is a Flask application that presents a REST API to the world. Next, we have a database that stores not only devices, hosts, and services, but also things like scans and packet captures and things of that nature that is writable, and also we can read and filter from it. We understand about messaging, so we can send messages to a message broker that queues them up and that can then be retrieved by a consumer of those messages. We've got object-oriented stuff where we've got classes defined to do stuff. Those classes, furthermore, are threads. So we've got threads and concurrency going on here where we have different functionality that's actually getting launched and executing. Then we've got HTTP going on where we're actually sending HTTP stuff back here so that it gets stored in the database. So think of all the software functionality that you are now exposed to and that you have knowledge of. Even if you're not an expert, this is quite a long and deep understanding of just about all that there is to understand about software right here inside this little application that we've got going on. Not to mention things like user interface stuff, which we have dabbled in a little bit. So take a minute to pat yourself on the back. This is really an amazing accomplishment if you made it this far, and I'm super proud of you if you have. All right, so let's review what we talked about in this lesson. This lesson was about the Quokka worker and what it does. We started by talking about how our previous lesson discussed the creation of messages or the producing of messages, and how when somebody wanted a port scan done, we would go into this code and we would create a message that would go to the message broker, which is RabbitMq, and it would get put into this queue. Our Quokka worker would sit and listen to this queue. When it receives a message, it would create a thread and get it running, which would perform the work. And then the Quokka worker would immediately go back and listen. So at the same time that the scan was happening, the Quokka worker would get the next message. We showed you in a demonstration that we could have multiple messages going on at the same time, and these would all get read by the Quokka worker or received by the Quokka worker, and new threads would get created so that these were all done simultaneously in a concurrent manner. We talked about how the message got passed back using HTTP in order to get put into the database for later retrieval by the user interface. We did talk about this message broker and how I hadn't talked about how you need to install it, but yeah, the RabbitMq documentation is okay, but we talked about how I actually have a description of what needs to get installed here, and so you can follow this as well. We did go through the code. So in this Quokka worker, basically what we do is we call this function called start receiving. Start receiving is going to set up our connection with the message broker. We will declare that we're using this particular queue, and then we will consume from this queue. We pass a callback that says every time you receive a message, I want you to call this one. And then from that point, once it has that information, we say start consuming. And now, whenever we receive a message, our receive work request will execute. We will take the body and we will translate it into Python data. We will then process the data, and our processing of the data is basically depending on whether it's capture, port scan, or traceroute work type, then we will create the thread. I mentioned I've only created the port scan one at this particular point in time. And once we have created that thread, we call start to initiate it. The port scan thread is going to come into this run function. We will do our nmap stuff where we create a port scanner, we do the scan, and then we process the scan output. Processing the scan output is mainly creating this information that we're going to send to our send port scan. Send port scan is just going to create the payload that will be sent, and we send the HTTP request to the server. And that is what you see in this part of the picture where we're sending the request to our Quokka server that will then get stored in the database. That's basically what we talked about. There's a lot of things going on. Our Quokka worker is running. I'm using the user interface stuff, which we haven't gone over yet, in order to initiate it, just so that it's easy to see what's going on. And yeah, that is our Quokka worker, and also a little bit about the message broker. Hopefully that made some sense to you anyway, and you're a little bit further down the path towards understanding how messaging works, producing messages, consuming messages, and our design, which is basically to have a single worker that listens for messages and then launches threads to process them. If you have any questions, as always, give me a shout using whatever means you choose. And until next time, thanks for listening.